We've been active now for about a year and a half, I think. So welcome. So I'm not your normal host. I'm Keith Casey. Our normal host, Travis Weisgood and Sandeep Marga, are out of town. The DjangoCon is going on right now, so they're all having fun, drinking beer, having tacos, that sort of thing. But anyway, we're going to have beer and tacos without them. So first of all, I would like to give a thanks to Basho for the beer and tacos. Let's give them a round of applause. Also like to give a shout out to Capital Factory. That's this space that we're in. They make this available to different user groups and everything. It's totally free of charge, which is actually a pretty cool thing to do. So round of applause for them, please. All right, now without further ado, because you're not actually here to listen to me, I'm just supposed to be the song and dance. We have a pair of presentations tonight. One, we're going to get an intro to Riak. So it's going to go ahead and kick things off. Here's how you get set up. Here's how you get going. And then we're going to dive into an actual use case. And you guys are using it in production and everything, right?
Yes.
Fantastic. All right, so first up we have Seth Thomas of Basho introducing us to Riak. Please, take it away.
So I'm Seth. I work for Basho. Actually, I totally ruined my first slide. So I'm a DevOps engineer. I'm not a developer by trade, so I don't actually use React day to day, except for performance testing, load testing, trying to figure out what kind of hardware is best suited for our customers. That's why I got Parnell, because he actually uses it and is very excited about using it. So he'll talk about the dev stuff. I'm going to talk about just kind of a general overview of what Basho does and a typical response during this call. So Riak. Riak is a distributed key value store. That is as simple a definition as it can be. It's based on the Dynamo white paper. So Amazon used Dynamo to back almost all of their services, S3, whatever it is. It's backed by Dynamo. We took their Dynamo white paper, and I don't have the graphic with me, but we actually outlined their entire white paper with highlighter to show them basically the same features that we cover. We have about 80% feature coverage of what Dynamo does. We wrote it in Erlang. It's a distributed language. It's a distributed database. It goes hand in hand. I'll get more to that later. We have advanced query features, so we have secondary indexes. We have full text search, which is a Lucene Solr type interface. And then we also have multiple storage engines that you can plug in on the back end. Right now we only have two, and I'll get to that more. And it's open source. We do make an enterprise version. There's really only one feature in the enterprise version, that's multi-data center replication. And we'll talk about that in the context of how Riak does replicate. So, key value, bucket. That is pretty much all Riak does. We have buckets. Buckets aren't really, it's a horrible name because buckets aren't really like you think of, they're not necessarily containers. You can have a bucket that is, say tweets. Most of our data is accessible or all of our data is accessible either by HTTP API or a protocol buffer. Just depends on what your performance needs are and how easy you want to make your life. So anytime you go to a URL for Riak, it'll be /Riak/bucket name. All of our keys are there. A key, the bucket and the key together is how you find all your data. There's not really, you can't really just search by keys. So bucket and keys. So I guess the real elegance behind Riak, there's no master, no slave, no, I have to shard this or whatever. It scales horizontally and in theory infinitely. So you need more performance, you just add a node. You need more fault tolerance, you add another node. No node has anything special. Every node runs the exact same things, and all nodes can coordinate with each other. And I'll talk about that a little bit, how they actually accomplish that. That's the idea behind it. So this is the big bit. Consistent hashing. This is how we accomplish distributing our data between all the nodes. 160-bit integer key space. Shows 160 bits because that's SHA-1. The reason that it's represented as a ring, you'll see in a second. So this is actually we go around the ring. So as you distribute the data between all of your different nodes, you'll just roll over the ring and determine which nodes the data actually rolls to. So we divide it into 4 partitions for 4 nodes. The partitions are something you set when you set up the data store. So it's something very critical to think about when you want to determine your ring size. You can scale that ring size out infinitely, The problem is it may not, you're going to hit performance concerns if, say, you set a ring size too small and you scale it out, or you may have one machine only taking one little tiny piece of the ring, and it's not really a good way to set it up. So that's something that we actually have calculators that are available so that you can find out the best way to distribute data based on your data set size. We have a bunch of little tuning knobs that you can pick that'll give you kind of a good number. The default is 64. It works for almost all use cases unless you're a huge customer. So, the Dynamo white paper and Riak both are based on the idea that you have a quorum. So usually the default value is n equals 3. So 3 nodes have to be up. They have to agree. You can tune these quorums per bucket. So each bucket you can say, hey, I want to have 2 nodes agree for writes. I want to have 3 nodes agree for reads. It really depends on what kind of data consistency you want and where your performance emphasis is. The more you have to have agree on a write, the longer it's going to take, and it works the same way for reads. So you write a piece of data, you push it, it goes to any one of these nodes, and it will go to the next 3 nodes in the ring. So here's where it gets really cool. So node fails. So our node, I think the green node is node 4. It fails. Once data stops going to that node, every other node that was part of that quorum can then redirect you to the right node that will have that data. Since all of these are storing typically 3 copies, there are going to be at least 2 nodes that have this data. Once this happens, data will then start to do what's called a handoff. When the node comes back or another node is added in its place, data starts to hand off. This does it automatically. Erlang coordinates the whole business. And you can actually see this transfer status with the admin tool. It's very easy, so you can see the actual percentage of data that is on each node in the cluster. And you can see, yeah.
Sorry, I have a question. So I come from a web hosting background. So when you say node, what I picture is a dedicated server.
Yes.
But could a node also be like a virtual server on Amazon, and then like you have another virtual server on Amazon, or potentially a virtual server somewhere other than Amazon?
Yes. Now, okay. So nodes. When I say nodes, I am talking about boxes, whether they're VMs or physical hardware.
Okay.
As far as nodes in different, if you're talking about Amazon, different availability zones, that I will address in a second. Typically, Riak is run inside of a single data center. I say typically because there are enterprise bits actually let you replicate between multiple data centers. That is what we charge for. The open source version, though, most go run inside of their own data center or inside of inside the same availability zone. Riak is very latency sensitive, or if you want the high performance, it's going to be latency sensitive. So one of the problems we've seen with EC2 clusters and I guess cloud services is that network latency is almost never guaranteed, and that sucks when you're trying to do high throughput. We can saturate 10 gigabit links with Erlang. We use Boundary for our traffic, for actually monitoring traffic in our internal clusters. We have broken 3 or 4 switches already with the amount of data we've pushed through. We can get 8 gigabits solid, which is considering 20% overhead for TCP, we're saturated. So we'll get back to my handoff. So when the data, say a node fails, comes back in, it will hand the data back off. It will make sure that the data is distributed by the terms of the ring that was set when you first set up the ring. Easy to scale, I kind of covered that. You just add a node. Now I'm actually going to do a little demo to show you how easy it is to add a node. When you add a node, you just type Riak admin join, and there's another node. You don't have to do anything. You have to say, oh, this is a special, this is a new node, or Riak just knows what to do. It's written in Erlang. For those of you who aren't familiar with Erlang, it was written by Ericsson in the early 90s. It was written for telecom purposes. It's extremely fault tolerant, extremely scalable. Some of the highest uptime switches in the world actually run on Erlang. And they have something like 6 or 7 nines type of uptime. It's a great language. We've not ever been able to push Erlang to where it falls over before hardware, before network, before some physical piece falls over. It's really awesome, and it makes all of this failover and easy handoffs and everything possible. Erlang uses an actor model, so there's no shared state. Every Erlang node talks to every other Erlang node, and then what they do is they gossip to each other to tell each other about the state of the world as they see it. So between all of the nodes, you can figure out what the state of the world is.
So can the admin send configuration messages to any node, and then they gossip to each other?
Yes.
To spread them?
And you can do cool things since Erlang is a distributed system. When you log into the console and run and you send a message, you can actually use distributed Erlang to talk to all the nodes at once from the console. So you can on the fly change configuration options, a lot of really cool stuff that you can't necessarily do with other applications that aren't written in Erlang.
So when you have multiple nodes of Erlang set up in a cluster, when one node connects to another node, if there are 5 nodes connected to that one node, every node will automatically connect to each other. That's built into the Erlang virtual machine. And you can also, distributed RPC is also built into the Erlang virtual machine at the language level. So it's a feature of the language. It's not just an add-on library or anything like that.
And this is why we chose Erlang. It's incredibly fault-tolerant. Riak also does pre and post commit hooks, so you can do just about anything there. You can use Erlang or JavaScript. We just picked those languages. Erlang, obviously, because it's already part of it. JavaScript, because it's very easy and a lot of people use it. Backends. We use 3 different backends. Bitcask is one we cooked up ourselves. Bitcask is a log structure backend, so it just appends to the end of a file. It keeps an in-memory hash table that tells it where to go. The idea is that we keep everything down to at most 2 seeks to find it, to actually find data or write data. It's really, really fast. It's the default that we actually recommend. It does suffer from a few shortcomings, which is why we added LevelDB. LevelDB is something that Google develops. I believe it's based on Bigtable. And LevelDB has features secondary indexing, full text search are much, much faster on LevelDB. So if you want to use some of the more advanced features of React, you're probably going to want to go with LevelDB. One of the cool things that we allow multiple backends. So you can have a backend per bucket. So you can have a Riak ring that has one bucket that's Bitcast, one bucket that's LevelDB, another bucket that's in-memory. It just depends on your use case and how your data is structured. One thing about Riak to kind of be clear about, there's no SQL, there's no schema, and there's no structure. You're going to pick that, and you're going to probably do that in your application layer. The in-memory DB is exactly what it says. It's just we just put everything into memory. It's fast because it's in memory, but it doesn't write anything to disk, so it's it depends on what you're doing. If you don't really care about the data, use the in-memory. LevelDB, we actually contribute code back to LevelDB, which is really awesome. So we get to work with the Google guys on it and make it a little bit better. LevelDB is a log merge tree format, and so it's very, very fast. It runs everything in memory, but it writes to just incredibly fast, and then it kind of does it compacts the data at regular intervals. So it goes through and says, okay, I've written all these files out to now and compact them into files or into kind of like a base level. So that's why it's called LevelDB, is there are actual levels of files as you go from your original data out to your latest data. Your latest data will be loose files, and then everything else gets compacted up into big chunks so that it's more efficient to read. Right? So some of the features that we do, MapReduce. The cool thing about Erlang, it's distributed. So you want to do MapReduce, it happens on every single node. It doesn't just happen on one. We allow MapReduce in JavaScript and Erlang. Erlang is going to be really fast. JavaScript VMs are going to take a lot of memory, but if you don't want to write the Erlang, then it's an option. The Erlang stuff will be far more performant. Full text search. This is a really awesome feature, but I don't want to oversell it because it's not like it's a magical fast thing. It actually has to go through all of the data. It's very fast, when it's distributed, but it's still a heavyweight. Secondary indexes.
Does a full text search do a full key, traverse the entire key space?
Yes.
I thought it did, yeah.
Yeah, so it's not something you necessarily, it's there, but you want to do it off hours, or it's there for specific purposes. Secondary indexes, they're there as, just like you would, if you want a little bit of your relational world, you can use secondary indexes. You can do those with pre-commit hooks, post-commit hooks. Secondary indexes are stored just as metadata alongside your regular So if you want to have some kind of relational mapping, you can use secondary indexes. Now they are not fast. There's not as fast as if you're just natively querying Bitcast or LevelDB, but it's pretty fast. And it just depends on what you're actually doing with them. It's a heck of a lot better than listing all of the keys, though, because that can take a long time. So we just okay. No, go ahead.
That fast.
It depends on your hardware and how much memory you're actually, how much of the system you're actually using already with maintaining the actual Riak node.
I guess relative like to a key lookup is a secondary index lookup 2, 4.
I really don't know. I just know it's slower. I haven't actually, on most of the times I've had to use secondary index lookups for testing. They've been really fast, but I haven't measured what the difference in like milliseconds is. It could be like a factor of 5, but I can actually find that.
So that's just your gut feel?
Yeah, just gut feel. Yeah, it's slower, and we advise people secondary indexes should be done with care. We're not trying to be a relational database, and we're not trying to bolt on relational features necessarily. There are some good uses for secondary indexes, and you could probably use
Yeah, there are. We don't use secondary indices, but yeah.
So we just released 1.2. I only bring it up because there are a lot of really cool things that came with 1.2. So it used to be you would just join a node to a cluster, and you just joined it, and that just happened. Now we allow you to stage commits. So say you want to join 5 nodes at once. When you actually run the join command, it just stages all of the nodes to be committed. So you can wait to commit nodes at an off hour because of the handoffs that are going to happen. You can stage certain sets of nodes, so you can do kind of a staggered set so that you don't actually overload any of the nodes with handoff traffic. It's really cool. I'll actually show that in a minute, but you can basically look at what the staging set is, commit it at any time, or you can clear it out and start over again. It was a small feature, but a lot of our customers have found it really useful. Used to be that if you wanted to do a rolling upgrade, you had to be very, very careful about it. Now we actually know all the different versions, all the different settings in Riak 1.2 is aware of. So if you do have different settings on different nodes, running different versions, it will negotiate capabilities between them and set a baseline. And until those nodes roll out, certain features won't be available, but it won't break your existing link. So you can do a rolling upgrade along this.
So there, are you talking about upgrades of your Riak version?
Yes, upgrades of my Riak.
Not of your data structure or?
No, I'm sorry, yeah. This is so if you're going from Riak 1.1 to 1.2, it will automatically negotiate capabilities between all the different nodes. Handoffs are, like I said, when the node is joined to the cluster or dies or something and it starts handing off data. We've added a lot more stats around handoff traffic, so you can see exactly how many partitions are being transferred, so you can kind of get just a bit more visibility. It always happened pretty reliably in older versions, but we didn't actually show it. Used to be if you need to repair your key value search, so it does what's called read repair. So every time it reads the data, it checks with the core and repairs it if there's something wrong with one of the nodes. The problem is that if you want to do that across the entire cluster, you had to list all of your keys, which if you have 1 billion of them, it's a long time. So we actually now have a way to do that in the background from the console. More stats with Folsom, so we've integrated the open source Folsom package, so we can show stats through that. And I know Parnell likes this. We have official packages for FreeBSD and SmartOS now. That was one of our big things. And then EDS only. EDS is our enterprise version. The bits that we actually had people pay for are replicating between data centers. It's very, very hard to replicate. Erlang likes to be low latency inside the same data center. When you're replicating over high latency links, high latency, low bandwidth links, that's what the EDS version does very, very well. It's not very many lines of code, so like I would say like 98% of the code base is open source, and it's only that like 500 little lines that do the multi-data center that you actually pay for. We've improved how you can replicate. You can do full-time or full sync, real-time syncs, whatever suits your boat or suits what your performance needs are. We also encrypt everything end-to-end. In the past, multi-data center replication required you to actually run like STUD or something for SSL termination. That was very cool, so I figured we fixed that. This is a new product, React CS. If you guys have ever heard of S3, that's what we're doing. It's the same deal. It's an S3 compatible API. It's backed by Riak, in the same way that Dynamo backs S3. That's really all. I won't go into it. If you use S3, you know what it is, but the advantages of it are it's multi-tenant, so you can do billing, you can do all those fun things. I don't have a whole lot to say about React CS, it's pretty good. But here's what it looks like.
When is it first released?
React CS was announced earlier this year. We had been working on, I think, February of this year. Right now we're on 1.1. We've been working on it for a while. Since it's backed by Riak, it didn't take a whole lot of effort this is just another layer. This is just another Erlang process that runs, and it does the things like breaking up the files into chunks and distributing them among the Erlang nodes. Most of the heavy lifting is still done by Riak. We do have certain settings for the backends that make it more applicable to large object storage. Right now we have, I think, a 5 GB file limit, but that's just arbitrary because we haven't tested a lot larger. And else. Oh, and yes, we're hiring people. Come work for us. It's awesome. And if you're a DevOps person like me, we need you really badly because we're trying to figure out the limits of scale and serving some very, very large customers where they're like, oh, we've got 150 nodes. And we're like, we don't have 150. So we're building out data centers across the world and doing a lot of cool stuff and playing a lot of different. We're also having our own conference later this year. If you're into distributed computing, it's not just about Riak, it's about distributed computing as a whole. We have folks from Twitter, I think we have Twilio. We have, let's see, who else do we have? Folks from Stratus, a bunch of other big distributed computing players. That's in San Francisco, and I encourage you all to come. It's going to be awesome. Any questions about Riak before I hand over to Parma?
Where are you located?
We are, like our database, we're distributed across the world. We do have offices in San Francisco and Boston. I'm located in Austin. I think that maybe 20% of the company is between the two major offices. We just opened an office in London and in Japan, but those have like 2 or 3 people working at them. Everyone else is wherever they choose to be. Yeah.
Are you going to show a demo?
I am going to show a demo. I just want to get questions out of the way first. So, when I say it, it's like super easy. What I'm going to show you guys is how easy Riak is. So this is, I just built Erlang, or not built Erlang, built Riak earlier today. I did have to build Erlang. It can be harrowing, but it's not as painful as it sounds. Oh yeah, if you're going to use Riak, make sure your U limit is set like really insanely high. He's laughing because he knows.
Especially with level DB.
Yeah, you want to have like if your U limit, like most U limits are set like really low, like 1024. We recommend that as the minimum. OS 10 sets at like 256, which is really low. Most time we set is like 65,000. Trust me on this. You'll want it. So,
What does U limit do? Is that like the number of connections?
number of file handles opened by the operating system. We touch it gets really crazy with level DB with the amount of this, with the number of files it generates. So you want to have a really high U limit. Usually we run into OS problems before we run into problems with Riak itself. So we do a lot of advocacy around tuning. There's a lot of network and OS level tuning that can be done. So Riak is now running. So I have a single node running right now. And I run a ping, and I get a palm back. Actually, let me raise this up so you guys can see this. So I want to add 3 more nodes to this Riak cluster. So I'm cheating. Doesn't want to find it.
So each dev directory is a different React
Yes,
install?
each so dev 1, 2, 3, and 4 are each different React installs. We have a make setting that basically when you make the dev release, it generates 4, or you can change it to 7 or however many. It's very useful for demos. I think that's the only reason that it's actually in there. So I'm going to start up the other dev releases. I should get a little warning every time because I haven't set my unit limit properly. So now, just to show you that they're all up, should go on back from each one, 15 other bashing. So they're all running. And now,
How is it connecting to the instance it's running? Did it drop
so everything is done through the Erlang. It uses what it's called the Erlang cookie, or a cookie, and it keeps naming. So each one of those binaries is looking at a config file inside of that directory, and each one of the dev nodes is labeled dev1, dev2, dev3, and dev4. So that's it.
Riak is structured very heavily around the way Erlang and OTP structure telecom applications. And so a lot of what's going on right there actually is very specific to how Erlang OTP structures their apps. When I come up, because I'm also an Erlang programmer, when I come up I can talk more about the specifics of how a lot of those things actually work.
Oh, yeah, I'm going to let him do that. Erlang is not my strong suit. So, what I'm going to do right now is tell each one of the other nodes, and I need to tell node 1 to get out of there, to join the dev1 ring. So dev1 is already instantiated ring. The other nodes have started up, and they have their own rings as well. But once you say, hey, join this other ring, it's going to dump its data, and node 1 will be the authoritative node. So now it says it's staged the request for each of the nodes. Now what I can do So this is the staging I was talking about. It's actually going to show me exactly what the state of the ring will be once I add the nodes. Now the nodes aren't added, they're just staged for a commit. Before this would just happen, they would just all be added and you would just have to deal with the handoff traffic. We did this because, like I said, there are certain instances where you have so much data that you're going to overload either your network or overload disk subsystems on your servers. So this makes it a lot easier. So you can see 16 transfers are going to happen to each one of those 3 nodes that I'm adding from dev1. And then, when I'm ready to do this, I just hit commit. And now, our Riak admin command has like tons of subcommands. It's really, really easy.
Yeah, Riak admin is awesome. It's a sysadmin's dream come true. It really is.
As an ops guy, like this is great. Like I don't get Nagios alerts at night because like I can have like 10 nodes die and I just don't care because it just hands off data. This is one of the things that we found with Riak is developers like it. Ops guys love it because there's no problems. There's no scaling problems. There's no, I mean, we need to add hardware, we need to add nodes. That's it. You just add them in. You can see. So now the ring is already distributed. So you see between those two, and granted there's no data there, but it's, you know, whatever the default stuff is, valid for it shows who's exiting, who's leaving, who's joining, who's down. It knows all of this, and I could actually query any member of the cluster, and it would give me the same answers. That's the magic of it. I think I hear my Mac. So that's the demo. I'll leave it to Parnell to explain the rest.
Question.
Oh, sure.
If you suck at selecting your keys and you have hotspots, can you reassign it manually, which the token space to the nodes, or is this going to be done equally?
So it'll always be done equally.
Yeah.
That is how it's designed, and we've actually had that question before. Folks have asked, can we put like part of our key space on a bigger server and like a faster one? The idea is that everything should be equivalent. We don't want to make, the idea is that we don't have a special one. So we were trying to get away from the whole, well, we've got a really powerful master server and kind of a dinky slave server, and this particular heavy traffic key space is sharded. We wanted to avoid all of that. So you don't do anything special. The only thing is, like, say you want to change your ring size, you're going to need to bring the whole cluster down and actually re-import your data. That is one of the only things that Riak can't do on the fly, is change your actual ring, your originally set ring size. Other than that, it pretty much can do everything better. That's all I've got.
Cool.
All right, thank you, Seth. Next up, we have Parnell Springmeyer, who I just found out their company, Whoosh Traffic, is based here. Like, not here, but like on this floor.
Hi.
There you go. So that's very cool. We still have beer and tacos. The goal is to have no beer and tacos left at the end of the night. So if you can help us get to that goal, that'd be awesome.
I don't want to eat them all.
Yes. Seth has to eat all of them before he can go back to the.
Let's not eat any. See how he does.
I like the way you think.
I picked my favorite taco place in case this happened.
Ah, you could
This
stretch.
is- I didn't want to cheap out on tacos.
Dude, I have no time. Like, I really want to, especially for like DB upgrades, performance upgrades.
It was a lot of polish, and we got your free BSC packages officially supported. No, you don't get anymore. The Smart OS guys are really happy too.
I think I'm probably gonna wait for a few sub-releases just to make sure that no kinks are ironed, you know?
There are a few. I would wait. It's very stable right now, but I would just say wait for 1-2 weeks.
Probably gonna wait and hire a free BSD system just so that I can take that crap off my shoulders.
We only found out one issue that came with a customer. It was because of somebody tried to fix one thing.
Yeah.
Made another problem, but it only happens with like a full key list, which of course this customer is doing exactly that. It was just like a crazy condition. It was like, So release them a patch for 1.2.1 fix.
For now, the network is fast. Is the 4G really clear battery? I know on my text just dies in like 2 hours. Yeah.
So hi, I'm Parnell Springmeyer, Voice Traffic.
Yeah.
My co-founder is Erica Douglas, sitting right over there.
Hi guys.
We are Voice Traffic. You can find me on GitHub, on Bitbucket. I'm the CTO and co-founder of Voice Traffic. I'm an Erlang, Haskell scheme, Python programmer, yada yada yada. I'm also a Riak enthusiast. Voice Traffic is a small bootstrap SEO tools company. We produce tools for internet marketers, SEO professionals, agencies, and small business owners and website niche owners. We provide 3 major tools. The competition analyzer. For example, if you want to analyze your competition in Google search and you type in "make money online," it'll analyze the top 10 results, the websites in those top 10 positions, for how their on-page SEO is looking, whether they have the keyword that you're searching for in the title tag or H1 tags, or et cetera, et cetera, et cetera. We provide a rank tracker, which tracks your website's position given a search term through Google's index. That's a really complicated product, and I'm not going to go into that since this is the NoSQL media. We also have a keyword research tool that scrapes Google's AdWord keyword data. Primary reason for doing that is to mash it up with a lot of our other data and potentially data from other sources as well. We are in Erlang, Python, FreeBSD, Riak, MySQL, Nginx shop. We also use Redis. So we're a polyglot and polypersistence company. Just a few images of our products. This is the competition analyzer tool. This is our rank tracker tool. And this is our keyword research tool. Okay, Seth gave a pretty good overview, very good overview actually of Riak. I was assuming that he wasn't going to do that, it was just going to be me, so I put a little bit of a slide in here about it. He went over all of this stuff. The awesome thing about Riak is the fault tolerance features. If a node goes down, each node starts distributing stuff to all the other nodes automatically. It's horizontally scalable. Every node is sovereign. There's no special nodes. All that fun stuff. So our technical challenges were pretty typical for React's use case, actually. We were a very write-heavy application. We had fast-growing data. Part of our rank tracker, actually, when we find your rank in the SERP, we also take the page that we found it on, Google's HTML, and we store that as well, so that we can display that to the user and say, this is where we found your website in the SERPs. This is sort of like proof. And downtime really sucks because our rank tracker runs 24/7. It's always running. So if the DB goes down, then the rank tracker freaks out and we get a lot of data corruption. We get all kinds of nasty stuff happens when the database goes down. So Riak, when it's distributed, I mean, we have nodes go down, but it never harms our write consistency in that sense. Riak is an eventually consistent database, so you still have to deal with conflicting children and stuff like that. But in terms of having corrupted data because your database puked on you, that's pretty much solved by Riak, which is really nice. We were using NoSQL for everything, and it worked really well. You know, when you're really small and you're doing really low latency stuff. But the minute you start jamming a lot of data in there, and the minute you start trying to pull that data out, it can get pretty yucky when you're pairing that with a web server and a web application. That's also hitting pretty hard. A lot of the things that MySQL is not really good at was the fast-growing data, heavy writes, especially in an InnoDB backend. The slave replication just was terrible. It was painful beyond belief. So we're using React. So we don't have to do joins anymore. So the problem was in our rank tracker we have results that are stored by unranked pairs and ranked pairs. To find unranked pairs, we were doing joins on. We were doing full table scans on the results table to check for unranking pairs, which was really painful. Bad database design in the beginning, but Riak solved a lot of our growing problems, and so I rewrote the application to update our pairs with whether it's unranked or ranked, which sped up a lot of our queries and sped up getting results and stuff like that. Riak, as you saw from Seth's slides, is really, really easy to administrate. You add a node very easily. You can bring down nodes very easily. Nodes go down all the time. I mean, I have monitoring all of our nodes, and when a node goes down, it just restarts it, and it happens very easily. It's very easy. It's very, very effortless when it goes down. Yeah.
I just wanted to add, since I'm Parnell's co-founder, to give you some idea of what we were looking at before we moved to Riak. We had a Fortune 500 company is one of our largest customers, and they're tracking keyword rankings for over 400 different websites. So they had upwards of, what was it, like 4,000 different keyword URLs? Yeah, they have 7,000 different, now they do. They've been adding new sites on a daily basis. They have 7,000 different keywords and URLs that they're trying to track with their service. If you imagine loading that kind of results page, it was literally taking between 2 and 10 minutes to load the results page. And so Parnell, we kind of like scraped along with them, and they were like, is there anything you can do to speed this up a little bit so it doesn't take 2 minutes to see our ranking results? So Parnell implemented some caching on the back end. When we ended up moving to Riak and rewriting a lot of this stuff, which took quite a while, it was worth it because we actually were completely able to remove the caching in its entirety. So now when a customer requests all of their rankings in Google from our system, not only does it not have to cache that, which was annoying for everybody, but actually it displays really fast, and it's able to pull from Riak extremely quickly. So that was a huge, not just a benefit to us or something more fun for programmers, but it was a really noticeable benefit for our customers as well.
Well, you also get out of LevelDB. We use LevelDB as a backend of Riak. You get from LevelDB is it's got a, LevelDB has its own cache, and you get the larger you set the cache, the more data, the more recent data you put into LevelDB, that data is cached in memory. So lookups in LevelDB they're just lightning fast. It's almost like using Redis in between your write layer. And it handles the compaction for you, so you don't have to write all that application code to deal with a cache invalidation when your writes are older than some other writes. So it's super fast in that as well. Our rank tracker, which is the app that uses React the most, other than our web app requesting the data, but the writes come from our rank tracker. It's also built on Erlang. It's distributed across our cluster, sharing nodes with React. It runs 24/7. Generates about 50,000 data points per day, and I mean I know. Yeah.
So you said it shares nodes with Riak?
Yeah. So we have a 5-node cluster, and each node is a React node. It's a physical node and a logical node, and then each node also has a worker of the rank tracker. So the rank tracker is on this node, it's on this node, it's on this node. It does pretty much the same thing that React is accomplishing with distributing the workload, so your latency, your computing latency is lowered. That's how we're using it. And so it was a very natural fit to have the worker nodes on the same nodes with React, and that you can just write directly to that node, and you don't have to worry about pushing a lot of data over the wire. And then it reduced the amount of work that the entire cluster was doing as a whole.
Is that especially true because you wrote the worker in Erlang, or is that just generally true?
Generally true. I mean, you could do this using Celery and Python if you wanted to, or Scala, all the other distributed options out there. Let's see. The worst part of it was the HTML Google search that we were storing. That was those are large pieces of data. Sending over the wire it really sucked, sending a lot of that data. And so it was a lot easier for us to sort of drop it directly on that node, that React node. It was really fast. And then React in the background handles the handoff to all the other nodes. So that sped up, that reduced our latency in terms of the computing, the amount of time to compute a given set of pairs. Okay, we use React 1.1.2. React 1.2 just recently came out. It has a whole lot of fixes in it. It's got a lot of the features that Seth was demoing for you in it. I highly recommend it. I don't have the time to upgrade to it right now. If you know of any FreeBSD sysadmins, that would be awesome, because we're looking for them. We have a 5-node cluster. We use LevelDB. We do not use secondary indices in React at all. I didn't see a need for it. It came from my, well, I'll get to the next one. Pretty much described all that stuff. So I found out that when I first set up our application to use React, and I was using the JavaScript MapReduce API, Basho's official Python client doesn't actually have any connection tooling in it officially right now. And that was a problem using the protocol buffer API because it used the raw sockets module out of Python. And there were a lot of issues with deadlocking in threads with the socket. It was trying to share the same socket connection across multiple threads in our Python web application, which was a big problem. And so I was using the HTTP API because you got a lot of that stuff was dealt with by pooled HTTP connections. So that was fine, but the HTTP API is really slow. You only want to use it for test cases and that stuff. The real fast interface is the protobuf. And then I also found out that the JavaScript MapReduce API is just slow. If you're going to write something in production, you shouldn't use that at all. And it kind of sucks for people that don't know Erlang. Luckily, there are some pre-built Erlang MapReduce functions that you can just call rather than have to write the code. But if you want the speed out of the entire cluster and what Erlang gives you, you got to write it. You got to write it in Erlang and do MapReduce in Erlang. When I re-implemented our results page loading logic with the Erlang MapReduce API, it sped up by a factor of 2 or 3. It was really fast, really fast.
That's relative to using the JavaScript?
Yes.
Yeah, you should always use protocol buffers and Erlang when you can. We put the other ones there for ease of use, but if you want speed, Erlang protocols.
If you want to use the Python client for whatever reason, and you have a web app, there's there's a pull request on the main repository in GitHub. I added a G-event connection pooler to it, so it works using a protobuf API now in a threaded environment. So now our results page is fast, it's easy, it's scalable. I'm not worrying about joins. I'm not worrying about a lot of this other complicated stuff. The space is a lot flatter. It's a lot easier to reason about for me. It's a lot easier for our entire application to produce results, and it's just faster. Makes our customers a lot happier. It's homogeneous. You can throw a client, you can throw nodes at the problem. Yeah.
So I was curious, when you realized you were not going to be able to stay with NoSQL, were you evaluating anything with Riak?
I've heard a lot of horror stories about MongoDB. Well, let me get into, so when I first started out, approaching the problem of getting out of MySQL and how do I scale this, I first went the route of replicating MySQL, sharding, and that was a nightmare for me. It wasn't easy. It was unintuitive, and it was really brittle, really brittle. It was kind of yucky. If replication failed for whatever reason, it was really silent, and and all of a sudden you've got like 2 or 3 hours worth of data that's missing in your slaves, and now you got to go figure out, it was a mess. And so I started thinking about MongoDB. I started thinking about CouchDB. I was more partial to Erlang implementations because I'm an Erlang programmer. But those are the 2 top ones. Cassandra is interesting, but I didn't really fully evaluate Cassandra, to be honest. MongoDB I did not go with because I've had a couple of friends that had anecdotal stories about just bad experiences with MongoDB and the sharding problem, especially with master failover, that being a major problem for them, and it not being really flexible enough when in a fault-tolerant environment. So if you have just a node failure for whatever reason, you run out of memory and the node crashes, what happens, particularly the write master. But I don't know that much about MongoDB personally to make educated points on that topic. CouchDB I don't think is a very great solution for highly distributed, highly available database solutions. It's really not meant for that, in my opinion. It's a great database. I love CouchDB, but it's not great at doing what Riak does really well or Cassandra does really well. A common theme I see on the mailing list, what was common for me in the beginning, is a misconception by a lot of people about what Riak is well suited for. When I decided I wanted to use Riak in our application, I did it the complete wrong way. I started thinking about, well, this is amazing. It can scale out automatically. You can do all this stuff. I'm just going to put everything in Riak. And then I started thinking about, well, now I got to start building all these secondary, doing my own secondary indices and tertiary indices using all these buckets. And then there was all this application code and logic, and it got really complicated really fast. And now I'm redoing, relational calculus or relational algebra. Instead of using tools that already exist for that stuff that smarter people than me have already built. And I slowly started molding my view of the situation to, well, why don't I approach it the same way that I approach our application programming code? We use Python for our web application, we use Nginx for our web server, and then we use Erlang for a lot of our really, really heavy computing needs. So I decided Riak would be great for the fast-growing data, for the write-heavy data, for the stuff that we would just need to keep throwing hardware at the problem. And I looked at the kind of data that was growing slowly and that was not as write heavy, but was really heavily relational, that had a lot of dependencies on it. And it was pretty clear exactly what stuff would fit into Riak and what stuff should stay in MySQL. And our MySQL database rose by like 20 or 30 megabytes per day. It's really, really slow. I mean, barely anything being added to it. Whereas our Riak, each node gets probably about 4 or 5 gigabytes per day, grows by 5 gigabytes per day probably. So it's much more capable of handling that. 5 gigabytes is a little bit much.
It can do 5 gigabytes.
It's more like a gigabyte a day. One little gotcha with level DB that I found out along the way was that if you try to get a key that doesn't exist in level DB, you get smacked really hard in the face with disk seeds. Because level DB will go, it's leveled, and so it will seek through all of the levels to find the key, which takes a lot of time. It really slows down that operation badly. So it's really important in level DB, if you're using level DB, to know your key space. Bitcask isn't as bad at it because all the keys are held in memory. But Riak is one of those solutions where you should know your key space. You should be able to at least figure it out or store it. That's how we do it. We store the keys for the results in the pairs. The tools for Riak kind of suck. I mean, the Riak admin tool is awesome for sysadmins, but as a developer, it's nice to have like Navicat or SQL Yog where you can browse your schema and write queries and see stuff, or do like a count on all your indexed objects in the database and stuff like that. You don't have anything like that for Riak. I think MongoDB has stuff like that actually, which is the nice thing about it, I think. But Riak doesn't have anything like that. There is a web interface tool that I think is fully released now.
Yes, Riak Control.
Riak Control, which gives you like a node status panel, and it lets you see the ring partition status of the whole cluster and stuff. But you can't do things like really query the cluster or buckets and get key listings and stuff like that yet. I'm sure they're planning something like that for it. But, yeah.
Check that. What is level DB?
Level DB. So level DB is Riak has multiple backends for it. The main ones are Bitcask, level DB, and
The in-memory one. We used to have some others, but
the in-memory one.
We're not going to
yeah,
talk about it.
and they deprecated
Level
that.
DB more like storage engine?
Sorry.
Is level DB more like a storage engine?
Yes.
Yes. So yeah, all when they say engine, that's what they mean, the storage engine. Yeah. Yeah. But level DB is used by Google's Bigtable, and Google released it open source a year or two ago, I think, and it was pretty
Just
awesome.
like MySQL uses DB and other stuff.
Yeah, there's MyISAM, there's
So similar
DB.
fashion.
Exactly.
We used to actually have an InnoStore backend as well. We used to have one also called Debts. We've just deprecated them because they weren't performing nearly on they weren't accelerating like Level DB was. Level DB is getting a lot of attention from Google and a lot of other people. Bitcast we wrote ourselves, so of course we have interest in keeping that going. But we just dropped those off because the use cases there weren't enough people using it, and it didn't make sense to support it. So we kind of threw all of our chips into those two backends, and then the in-memory one I don't really consider a backend because it does never write anything to disk. But that was just we deprecated those old ones as of 1.2.
Redis is also a key value store, right? What's the difference between Riak and Redis? It's just distributed system kind of.
Well, there are quite a few differences. I mean, Cassandra is a key value store too. Redis is. Redis is more of an in-memory, more of a directly in-memory. Redis supports a lot of data structures too. Their goals are different. I mean, Redis is more about speed of lookup on the same machine as far as being highly available and fault tolerant, it probably doesn't meet any of those criteria. But React does.
It's great for caching and stuff. I've
Yeah.
used it, and we have people who use it in
Yeah, I use it
conjunction.
in caching too.
Yeah.
Yeah.
It's great for that, but for data that you actually want to store and you want to care about. And one of the things I think that I should probably make clear is Riak is, you don't want to run Riak on a single node. That's not how it's, that kind of defeats the whole, I mean, you can play around on your laptop or whatever with it, see how it interfaces, but until you've got like 5 nodes, you're really not getting the awesomeness of Riak. It's built for 5+ node clusters. So most people we know running in a production are running 10, 15, 40, 80. They're running large distributed data stores, whereas Redis you can run it on one box, and if it dies, well then you may lose caching or something. But it doesn't. Redis doesn't scale very well, horizontally, I should say.
We use 5 nodes. We're a 5-node cluster. Another gotcha for anybody that is going to deploy React is the ring creation size setting. Just keep this in your mind if you're going to play with React. If you're going to deploy it in a production environment, you have to set that setting before you start the node, because when you start the node, it creates the ring. It's sort of a one-off operation, and then any nodes that are going to join the cluster have to have the exact same ring size so that they can all agree on the ring. And that gets a lot of people the first time they use React, because they'll, I installed React, now I'm going to start it up and see what it's kind of like, and then they shut it down and go change the ring creation size and then start building their cluster, and then realize that the ring creation size didn't matter after they had started up the node. So that's something to keep in mind. Yeah.
How does that work when adding nodes on the fly? Do you have to completely bring the cluster down in order to increase the ring size?
That's part of the he was saying one major gotcha in React is that once the ring creation size is set, it's set. And if you want to change that, you have to dump all the data, you have to clear the configs and clear the rings and reset it, restart the nodes, and then reload all the data. So the general idea is to have an idea of how big your cluster is going to get, and then build and then configure the ring creation size based on that.
But you wouldn't have to change the ring creation size just because you're adding a node, right?
You don't have to change it because you're adding node, yeah. But it should be set to accommodate a median number of nodes for your needs.
Why don't you just set the ring size to the highest possible value always?
So that's a good question. And Basho has a calculator for all this stuff. So it's like number of nodes, amount of data you're going to store on a node, that type of thing that you can kind of figure out a good ring creation size for you to start out with. But say you want to set your ring creation size to 256. So that would be 256 partitions per machine, right?
Yeah.
Yeah, per machine. Now, if you set that really high, if you set it higher than 256, for example, and you have like a 4-node cluster, now you have a huge amount of partitions created on one machine, on each machine, and you get a lot of problems with disk seeks and searching on the ring, because there's so much partition of one machine, whereas if you increase that cluster size, then the ring distributes out a little bit more evenly across the
And when you do handoff, say a node fails, it's going to kill your disk I/O and kill your network.
That too, yeah.
Because when it hands off all the partitions to another node, and then you're watching 256 partitions being transferred. That's what you notice. Mine was like handing off 16 partitions apiece. When you have 256, it gets kind of sketchy. Or I mean, if your ring size.
So the more nodes you have, the fewer partitions get handed off, type of a thing.
So is Basho working on any ring size migration strategy?
We are. It's one of the, as Parnell mentioned, we pay attention to your key space and pay attention to your growth. We are working on a way with how the ring works. It's hard. That's one of the unfortunate kind of core things that we can't change. So we're working on ways around it. It's just it's far more effort than most of the other initiatives that we're pursuing right now, just because it changes kind of the fundamentals of how the whole thing works. But we are looking at being able to migrate ring size. A lot of the ways we have people do it when they're growing is they actually dump the data and instantiate a new ring. So you have multiple rings simultaneously, and then as you get new nodes added to the other one, to your new ring with a different data size, then you can reduce your one down to a minimum number of nodes. It does take hardware, obviously, or VMs or whatever you want, but it is doable, and you can do it with a minimal amount of downtime. But it does require very careful operational coordination.
So what happens if you add the 17th node in a 16 partition thing?
It will evenly distribute the keys as best it can. It doesn't. We actually have to. So yeah, all the integers for the ring size I think have to be like 8, 16, 60, 64 of that. Don't know what happens when you have an odd number of nodes. Other than you'll have a slight, if you actually look at the Riak admin cluster info, it'll be like you have some weird, a weird percentage. But it will be distributed to whatever your end value is, so at least 3 nodes will have that data. So there may be some nodes with slightly different amounts of data, but you won't have any data that isn't backed up in at least n number of places.
So when is your application going to hit that point where you can dump reload?
Very, very far in the future. I mean,
so it's not something that
I'm not really worried about it. I mean, like
Post IPO.
probably, yeah. But I digging around on the mailing list after I played with React and messed it up a few times, that sort of thing. Jumped on the mailing list and saw everybody complaining about the ring creation size stuff. I realized I needed to come up with a sort of general idea of how big I wanted the cluster to grow and how fast we were growing data-wise, and came up with the ring creation size based on that. And it's pretty important to start out with at least 5 nodes so that your ring creation size can be fairly large to begin with and not harm your disk I/O when you're doing handoff because of a node failure or when you add a node or something like that. So there is a good happy medium there that like 80% of users are going to fit into, I think. After that, you're looking at really huge cluster configurations, and those guys will usually have the money and the need to buy a large number of nodes to begin with, so that they can set a larger ring creation size that's not going to harm their disk I/O, that kind of stuff. So that was the rationale seen both from me and other people in the mailing list. That's about all I really have to say. I don't have a whole lot of demonstration code or stuff to share. It's kind of boring. I mean, you connect to Riak and then you run MapReduce on it and get some JSON values back. So I'm not going to bother showing that stuff to you guys. But, yeah, I was gonna tell you about Erlang and how it works. So the way OTP is structured is you'll have an application that's built on top of the Erlang virtual machine, and then you build a release, and the release will package the Erlang runtime and a bunch of its underlying applications that it uses and provides you into a combined release. And then when you deploy that, you have to have Erlang installed to boot up the runtime, but that runtime will start up and the virtual machine will treat that as its own logical node. So it'd be kind of like it's kind of like having an EC2 VM on top of hardware. So you can have
Each Erlang process instance is like that?
no. So
I mean OS process.
yes. So for example, if you run top and you have say you installed 2 React nodes on one dedicated machine, and you start them both up. If you look in top, it'll be beam.earl and beam.earl, or just beam. So it'll be 2 separate operating processes. So, yeah.
And then when you run the command, the Riak admin command line again, how does it identify the right beam?
So good question. In each release, you have those scripts and programs are contained within a release. So you'll have, React 1 is in a directory and React 2 is in a directory, and those programs are specifically tied to the running instance in your operating system. So if you want to, say you want to leave the cluster and you're at React 1, you'd have to go into React 1, go into the bin, and use the React admin program there to leave cluster. And then if you wanted to do something else with the other node, you'd have to do it that way.
Wouldn't it have to look it up with either a socket or a PID or a something
To be honest with you, I don't know what the precise internals of it are, because all of that stuff is actually generated by Erlang.
I know there's a cookie somewhere in there.
So that's a node. So that's called a node cookie. That is sort of a really rudimentary way of handling access control for nodes. So an Erlang node can be anything. It could be React. It could be a TCP node. It can be anything. You start it up and it's running. And then say you want to connect to another node. Both those nodes are going to have to share the same cookie, whether you're doing a distributed RPC, whether you're doing a TCP connect. If you want to connect to that node, it has to share the same. They both have to share the same cookie. So that's just a rudimentary access control on Erlang's part of all this. It allows you you can do interesting things with React with that, because you could set up a React topology that's multi-layered, in the sense that you could have 5 nodes and then 2 different nodes on different machines, and use different cookies for the different nodes, so that you could have multiple nodes running on machines that share different cookies, so they could be different clusters. That's obviously not a recommended way of doing things, but you can do that.
It will work.
Because you can.
Wait, it seems if you're migrating rings, that might be useful.
Yeah, you could do that.
Yeah, actually, you could do it that way, yeah.
I mean, you would be putting an potentially undue load on each node, but it would work. You can have, when we run, say, like React CS, that other layer, it's just got a different cookie. So it's got, the React node has, so we usually run those on the same node. So there's a React CS Erlang application, there's a React application. And one has a React CS cookie, one has a React cookie. And those cookies are arbitrary. You can name them anything, but that's just the default.
Is React CS, is that open source as well, or is that commercial?
That is right now it is commercial. It may be open source someday, but right now it's commercial.
That's the other 1%.
Yeah, that's one of those. It's new enough that we're trying to get people. If you pay for like React EDS, the enterprise version, it's usually customers who are doing that also want React CS, and so it's kind of been hand in hand. But that's actually something we're working out right now, licensing models. We do have a developer preview if you are interested. It's on. You just go to I think we actually have a reactcs.net site where you can actually try it out. Use like S3 command or whatever, throw some data at it. Since it's multi-tenant, you're not going to hurt anyone. We've got actually helped build the cluster that it's running on. It should be able to handle anything you can throw at it. Fingers crossed. But if you do want to try it out, it's available for testing. And you have to sign something saying you're not going to like use it for your production stuff or anything like that. So, although that would be amusing, and I would probably get an Nagios alert.
Yeah, that's all I got. Let's get to more questions.
Have you done any SSD testing?
Yeah, we have. Some of our customers use exclusively SSDs. I was actually going to say that with LevelDB. LevelDB and SSDs are really awesome. Like when you use them together, it's ridiculously fast. It depends on what kind of storage you're doing, or like how big your scale is. Once you scale it to a certain number of nodes, your disk I/O starts to matter less. And then again, it depends on how many partitions you have. There are a lot of dependent factors. But with like React CS, for example, since it's big, large object storage, and you're not doing as much seeking, you're just trying to get like a big chunk of something. Our test clusters are built using good old 7200 RPM drives. Granted, there are 12 of them in each server, so it's the writes are spread out.
Well, Netflix had that blog post where they went 48 machines down to 15 by switching to SSDs, and it ended up costing them less.
Oh yeah.
Even though they're so expensive.
Oh yeah, you can totally do that. We are actually getting in a whole new rack of machines, some of which will be, you guys have heard of like the Violin Memory folks. They do, it's essentially RAM disk. So we're going to be able to test Riak on RAM disks. It's just, I mean, it's like a big array that you put in of just RAM. It's like 144 gigs of pure RAM disk, as well as SSD testing. So we'll have hopefully some more numbers for that. We do have customers who are using SSDs, and it's working great for them. Usually we start running into networking overhead problems. Like I said, we've melted a few switches before. That's really where we get the problems. Most customers are like, "Oh, our performance sucks." And it's like, "Well, yeah, you've only got gigabit links between the machines. Like, why don't you get 10 gigabit?" And it's one of those when you're at that scale, 10 gigabit will make sense.
Fiber.
Yeah, fiber between everything.
Just curious, what about offsite backup? What is the strategy for that? It occurred to me, I know that EES gives you replication across different data centers, but I'm not sure if I've read or learned anything about backup.
That's actually a good question. We have a lot of customers. So our kind of way is, well, the nodes, the ring is always running, and it doesn't fail, so you don't need to worry about backing it up. And if you need a hot failover, well, multi-data center replicate. That's kind of. So it was one of those when people asked us, how do you back things up? We do have some strategies, and we're going to be posting something hopefully within the next month. With Bitcask, you can just back up the directory. It's easy. Yeah, it's just you just rsync it and you're good. Where it gets with Level DB, it's really weird because of how it compacts data. So you have a bunch of these loose files that get compacted, and it's constantly changing.
Even with Bitcask, though, not every node has the same data, right?
Not every. Sorry. Every node should have a, depending on your n size, should have all of the same data. Wait, hold on, did I say that right? No, with Bitcask, so you can back up one node at a time. As far as like data migration, I think we have a tool in either the contrib. I don't have my Wi-Fi hooked up right now, or else I would look up the wiki page. But we do have some strategies for customers to tackle it. That is a problem, though, and that we recognize. There's not an easy answer to say, I just rsync it, because it doesn't always work. Go ahead.
No.
Oh, is it? So yeah, we are looking at it. We are aware it's on our internal, like it's on one of our like we created like small little cabals to kind of attack all of the missing features, and that's one of the things is like, how the hell do we back this thing up? Because it just runs forever. Our theory is it just runs forever. Yeah, it's distributed. It just don't shut it down, obviously.
Data center burns down, we lose everything.
Well, that's the commercial.
Yeah, you replicate to another data center. It's very easy. I don't see the problem. So the part of the problem is our engineers didn't see that was the problem. They were like, well, I don't understand. How did you build fault tolerance in some other way? We are looking at. We are aware of it. I haven't seen anything recently on a good fix because we're trying to make it rsync happy, but said it's hard with. Yeah, exactly.
Well, distributed makes it.
Yeah. We do have a few large customers who are in more traditional enterprise spaces that are bugging us for exactly that reason, because they're like, well, we want to have it backed up somewhere offsite. We don't really have a good answer for them. We've cooked up some solutions for them, but I haven't actually looked at those yet. So.
Well, thank you. Thank you to Whoosh Traffic and Basho. So quick housekeeping before everyone takes off. Next month, the presentation is on Couchbase. We actually have somebody coming into town. They'll be doing the presentation. First Wednesday of the month, right here in this space. One other thing I'd like to do. Who's hiring? Show of hands.
Previous sysadmin
Okay.
contract. Please.
Stand up, say who you are, who you're with, and what you're looking for.
I'm Erica. I'm the co-founder at Whoosh Traffic, and we need a contract previous sysadmin. So that's what we're looking for. Austin or not, doesn't matter if you're local. Sysadmins can be anywhere. Poor Parnell is doing all this stuff on his own, and he's pulling like 70 hours. So.
Next up.
Hi, I'm Kevin. I'm the co-founder of Matt by Fitness, Matt by Run, Matt by Ride, which is down the street. We're looking for DevOps, backend, Python, a whole bunch of different things. So if you're interested in fitness apps, you can talk to me.
Anybody else? Seth?
We are hiring DevOps engineers right now, also a whole host of other stuff, but right now we're hurting for DevOps because I'm on a team of 2. So what's your email address? Oh, if you have any interest, it's sthomas, first initial last name, @basho.com.
Cool.
And just so everyone knows, this whole session has been recorded by Austin Tech Videos, and so has previous sessions by Refresh and other development meetups. So go to Austin Tech Videos and you'll be able to find them there.
It's awesomotechvideos.com. Okay, now, who's looking for work? Raise your hands. Stand up, say who you are, what your skills are.
Yeah, Richard Boldway, Ruby on Rails developer. Just finished a fairly large project over at Texas Association of Local Health Officials. The server handled 23,000 users, not all on at the same time. But I've been in the profession for 38 years. You go back to the days of what they call fat fingering, if you will. But it's been a long time since I've done that. Ruby on Rails, and primarily JavaScript.
All right, thank you. Anybody else?